Show that the value of, from 0 to 1, sine of x squared dx cannot possibly be 2. Okay, well, let's see what it looks like from 0 to 1. So we're showing that, oops, I put it on there this morning. There wasn't any place yesterday, but I think it's there now. Cannot be 2. Well, let's graph it first. Put in 0. The sine of 0 is, what's the sine of 0? 0. And I'm going from 0 to 1. All right, so let's think about on a unit circle. Is that my phone making all that noise? Oh my gosh, y'all. I need to answer this real quick. I'm sorry. He's at radiation. 1. I know I got pi over 2. Is pi over 2 less than 1? Half of pi. No. No. Oh. How about pi over 4? Pi over 4 is less than 1. How about, so pi over 6 I could have, pi over 4. How about pi over 3? Pi over, that's close. That's going to be a little bit more because 3.14 divided by 3 would be a little bit more than 1. Okay, so let's stop here and let's just look at it for just a second. What is, oh, gross. We're supposed to do this without, am I thinking about this wrong? What? Oh my gosh, this is the Max-Min theorem that we didn't do yesterday. Yeah. I'm sorry. Here. Don't do that. Net is net is on your calculator. That's like in deriv, that's in integer or in integral. Net, yes, that's math 9. Yeah. I'm sorry about 7. Nope, I'm so sorry. Okay, but I might not have said 7, so I'm sorry. That's why. If you did the max and the min, you'd see. I'm sorry. 11 and 13 are just on your calculator. Math 9. Yeah, you want me to show you again? For what, 7? 11 and 13. Because it's average value. You haven't done, I'm going to do average value today. I failed yesterday, y'all. OMG. Yeah, I thought I plugged it into my calculator right. And then I was like, well, that's not the answer. I'm really glad I didn't do it at all or even try because that would have been a big waste of time. Now it's homework is only 3 problems. On what? Yes, you can do 5. I mean, we can do 5. Yes, I'll do 5. Yes. Thank you. Yes. Oh my gosh. I even went, okay, never mind. Yes, 1 through 6. That should have been where we stopped. Oh, I just saw the net, as Adam says, and I thought that was good for you to practice with your calculator. Okay. 0 to 3. F of z dz. I'm glad y'all don't stress too much about. Y'all just. You're like, yeah. All right, find each integrand or integral. All right, so what is the integral from 3 to 4 of f of z dz? What can I do? Why'd you flip the first one? Here's what I would do on this one. Let's think about this for just a minute. This one's giving you the area from 0 to 3, right? That's your first integral. This one is giving you the area from 0 to 4. This one is asking me for this area. I would just subtract them. I would do this one minus this one. Right? Couldn't I do that? So if I do 0 to 4 minus 0 to 3, it should leave me with 3 to 4. Yes. Just flip it. Part B is, well, you were just supposed to do the odds because I thought there was some more, but it's okay. I mean, once you get the hang of these, they're not. It's just getting you used to those rules. Since we've already done from 3 to 4, we just take that 4 and go, it's negative. That's it. Well, I really let y'all down on those, didn't I? Sorry. Thank you. Anything else? Average value of a function. It's a pretty easy concept, but for some reason, when you see average value, you really want to do, your gut says, okay, well, let's find 2 points and let's just average them together, right? But that's not exactly what it does, and so that's where it kind of throws you off. But average value of a function, if I have, let's say, I'm talking about f of x, and I say, what's the average value of f of x on the interval from a to b? To do that, I would do 1 over b minus a times the integral from a to b of f of x. That is all average value is. So for example, let's say I said that f of x was 4 minus x squared, and I said, what's the average value on the interval 0 to 3? Yeah, tell me when you're done. Listen to how I teach you. You're very welcome. Oh, then who is that? Or maybe that's Nord teaching below us. Maybe he's watching a movie. Everybody let him win. They might be watching a movie. All right, average value. All I'm going to do, 1 over c minus a times the integral from 0 to 3 of 4 minus x squared. Now, if I use my calculator, this is an easy integral evaluation, right? If I don't, this will be a calculator problem until you learn how to do it otherwise. So I'm going to say 1/3 times and then take out your calculator. And somebody, oh, I'm sorry. One of y'all asked me to show you on the calculator, didn't you? Let me show you. 4 minus x squared is my function. You already got it? Are you sure? Oh, the overall answer is 1. The area under is 3, right? Okay. I was about to say, that's not what I wrote. But... So if you don't remember how to do it, I put it in y equals, but y'all with your fancy calculators, if you do math 9, it just comes up with the integral there. But we got 3 minus 3, 4 minus x squared. Do y'all like doing it on the graph better, or you like doing it? I like the graph. 6. And then I'm going to go second trace, and I'm going to choose number 7 from 0 to 3. And I get 3. Y'all okay? So this would be 1/3 times 3, which is 1. Do you think that at any point in this interval, the function actually takes this value on? Why? Yes. We did something like this when we were doing derivatives. What is it? It's the average. Exactly. Do you remember what that was called? The mean value theorem. Good job. That's impressive. The mean value theorem. And so we have the mean value theorem for integrals as well as derivatives. So at some point in here, it did take that value on. But that's the average value. Y'all good? Sure. Okay. Now let me show you. Y'all want to do one more? Or y'all? Let's do one we have to do by hand. Let's do. I like 16. 16 is no calculator. Y'all are going to have to think about this one. Pretend like those are equidistant. Ugh. It should be a circle. It should be a half of a circle. Coming down here with a radius of 1. Look at the picture in your book. Mine's terrible. It's a semicircle. I know that also based on the equation. This is the equation of a circle with a radius of 1. And the negative, of course, I've shifted up 1 from the plus. Reflected doesn't really matter on the circle. Okay, here we go, regardless or not. The picture is given to you. It says to find the average value of the function on the interval without integrating by appealing to the geometry of the region between the graph and the x-axis. Okay. Now, first of all, average value on this, the average value of f here, f of t, is going to be 1 over 1 minus negative 1, right? Times the integral from negative 1 to 1 of f of t. Everybody okay there? Yeah, Miss McGee, we're good. I'm glad. I'm so glad. Okay, good. Glad y'all got it. Well, I'm not going to write out f of t. This is a non-calculator problem. So instead of using my I mean, you can, Hope, it doesn't matter. But instead of using my calculator to find the integral, I'm going to have to look at this graph. So I'm going to have to reason through this because it said use geometry, use what I know. So from -1, okay, my -1 moves. From -1 to 1, the area under the curve. So down to the x. So I'm talking about these little pieces of funky little shapes. How in the world am I going to find that area? Does anybody have any idea? That's exactly what you would do. Good job. If I do the whole rectangle, I can find the area of a rectangle, right? That's easy. And I can find the area of a semicircle, right? So this whole rectangle would be 2 times 1. So the area of the rectangle would be 2. Then I can do the area of the semicircle. Do half, and then I do, how do you find the area of a circle? Pi r squared. What's the radius? 1. So 1 squared. So I just get pi over 2. So what's the area then of the red? Take the green rectangle. So the average value of this function would be 1/2 times whole minus the part, which would end up just being average value. Yeah. Why is that not what they got? Oh, this will be pi over 4. Sorry. That's what they got. Sorry. I got all excited. All those halves were going to cancel out. They don't. I just distributed this half through. Pretty easy. I think so too. I do want to show you antiderivatives real quick though, because this is your key for integrals, and this will be the first time you use it, and then I'll stop and let you work. Tell me when y'all got that. I don't want. You're good? Evaluating integrals, and I should say not integrals, but definite integrals. Definite means I have the bounds there. We'll do integrals where the bounds are not there. Definite integrals with antiderivatives. So if I have this, remember the integral, whenever I integrate, I'm going backwards from derivative, right? So I'm doing antiderivative. How do I indicate antiderivative? If f of x is my function, how do I indicate the capital F, right? So the antiderivative of f of x is capital F of x. Then what I do to evaluate this is I just do the antiderivative evaluated at the upper limit, and I subtract the antiderivative evaluated at the lower limit. I don't have to worry about a constant of it. Remember when we were doing antiderivatives and we had to do that constant of integration? We said whatever this is, if I wanted to know if this was just x, what would the antiderivative be? 1/2 x squared plus c, right? So where I go backwards of derivative. So instead of multiplying around, I divide, and instead of subtracting 1, I add 1 on the exponent, right? I don't have to worry about the plus c on definite integrals, because if you did plus c here and plus c here and you're subtracting, they cancel out anyway. So you don't have to worry about the c's is what I'm getting to here. But you do have to recognize the antiderivative and then plug it in. So let me show you an easy example, and then and this is weird, just barely dabbling in these evaluating definite integrals without geometry. This is number 19 for your homework. If I need to evaluate without a calculator, of course, this. I can first identify the antiderivative. What's the antiderivative of sine x? Careful when you answer it. Negative cosine x. That's exactly right. I got to make derivative of sine is cosine, but the antiderivative is sine. I mean, negative cosine, right? If f of x is sine, then this, of course, plus c. I don't have to worry about that whenever I evaluate them. Are y'all okay? So to evaluate this, I'm going to do negative cosine. I'm going to do the upper limit, so 2 pi, minus negative cosine of pi. What's the cosine of 2 pi? 1. So I got negative 1 minus, what's the cosine of pi? Negative 1. All right, so look at all these negatives. I think I'm going to go ahead and change this like this. Cosine of pi is negative 1. Y'all okay? That's the area. I can have negative area. We will talk about this later, but just since you asked, if you have, when you're graphing, think about the way sine and cosine, we got a curve, right? If you're under, this is negative area. If you're above, this is positive area. So it's under the, it can cancel out. You can have a total area of 0. Yeah. That's why that one we graphed where it was both and it added the negative, it had more positive than negative, which was why it was 3, but it had subtracted out that way. All right, y'all think you can do this? I think y'all can too. Okay, I'm gonna give you the right ones that you can do. This time, let's see, we're gonna do, we did 16, so let's try, 15 is a piecewise, but when you do 15, do each piece and then add them together. So do the average value of each one. You'll see what I'm talking about whenever you look at it. Separate them and add them together. You can do all those. You might need your derivative sheet to look. And on the back of your derivative sheet are the integrals. That might help you too for your antiderivatives. Average value of the function using antiderivative. So we're going to go through 35 odd. We're not going to do the max min. You think that's a lot? A couple more? You think? Well, you can't do 49. How about, this is a multiple choice, but it looks like those ones y'all hate where it says, which of the following must be true, or all of the following are true except, and 48 is multiple choice too. Is that enough? I know you good now. Y'all sure? There's 2 more I could give you. Okay. Throw them in there.